This video is going to look at an intro to volume in three-dimensional shapes. First of all, what even is volume? Volume is the amount of three-dimensional space that an object occupies. So let's go ahead and look at this rectangular prism we have over here to the right. If we wanted to figure out the amount of three-dimensional space that this occupies, we could go ahead and fill it with these unit cubes. How many unit cubes do you think it would take to fill this particular rectangular prism? Well, most elementary students would start to take the unit cubes one by one and start filling up the rectangular prism. 1, 2, 3, and so on. They would most likely go ahead and fill one entire row, and then they'd go and they'd start to fill in that back row. So here, we move this here, and then after they fill in that back row, they would start to make a second layer, and they would continue making layers until the box is filled, and that would tell them how many unit cubes fill the rectangular prism, and that would be the volume. Is there a shorthand to how we can determine the volume or how many of these unit cubes would fit in here without actually filling the prism with these unit cubes? That's right. If we can just figure out how many unit cubes would be in one layer, we could multiply by the number of layers without having to fill the entire prism. In fact, the formula for the volume of a prism is capital B times H. Now, this capital B, the reason why we use a capital B is actually because it stands for the area of the base. So even though it's a capital B, it's technically a two-dimensional thing. The area of our base in our rectangular prism was the area of the rectangle because that was the base. This H would then be the height of our prism. Notice, with this particular formula, we can actually find the volume of many different prisms. We just need to be able to find the area of whatever the base is. For example, if it was a triangular prism, we would find the area of a triangle and then multiply by the height. We can find a rectangular prism, we can find a trapezoidal prism if we really wanted, because we know how to find the area of all of those two-dimensional shapes. So that's the formula for the volume of a prism. Now, you may be wondering, what even is a prism? You keep using this word, but we've never actually talked about what a prism is. Well, a prism is a polyhedron. Now, what is a polyhedron? Polyhedron is actually a three-dimensional shape that is made up of polygons. We've been studying polygons since day one. So a prism is a polyhedron with two opposite faces that are identical polygons. This here is an example of a prism. In fact, this is the exact same rectangular prism that is on your note guide, and it is an example of a rectangular prism very similar to the one we looked at on the previous slide. Notice, the two opposite faces that are identical polygons can actually be any of these two opposite faces because we have rectangles for all 6 faces. Because of the way that this particular rectangular prism is oriented, I'm going to call the bottom, so this particular side, and then the top, I'm going to refer to those as the bases. So I'll write this here in blue, so we'll color code. if these are the bases, then what are the other rectangles, the other faces? Well, since those are upright, these, all going up and down, actually have a special name as well. These here are called lateral faces. Lateral actually means side. So these faces are on the side of our prism. Notice, because the two opposite faces will always be identical polygons, the lateral faces should always be parallelograms. Now, we technically have two ways that prisms can be classified. So one of the ways depends on how the prism is standing. Think to I know this isn't exactly a prism because its face is not a polygon, it's a circle, but think to the Leaning Tower of Pisa because I'm guessing you have all at least heard of that or seen pictures of it. That particular cylinder in that case appears to be falling over. If the bases are not aligned one directly above the other, it is called an oblique prism. However, the majority of prisms are aligned like this one that we have here, this rectangular prism here, where the base on the top is directly above the base on the bottom. Those types of prisms are called right prisms. In fact, think of the relationship of the lateral faces. If the bases are aligned directly on top of one another, the lateral faces will always be perpendicular to the base. So, when we go ahead and name our prisms, we need to make sure to say, 1, are those prisms going to be right or oblique? And then 2, we always go ahead and we name the prism with the name of its base. So, for example, if we want to name the above prism, this one right here, I've been referring to it kind of already by the name of its base. It is a rectangular prism. However, is it right or oblique? That's right, it is right. So we would call this a right rectangular prism. If a prism does not have the word right or oblique, the default is always that it is a right prism. That is why earlier in the lesson I was just referring to this as a rectangular prism and not necessarily a right rectangular prism. However, if it is oblique, you must say the word oblique. Why don't you guys go ahead, pause the video, and on your note sheet, sketch and name 2 other different prisms. Perhaps try to do an oblique one, or perhaps try to change the base. Go ahead. Continue the video after you're done. Now, you may be wondering, what happens if the 3D shape we have isn't a prism? Well, there's one other large group of classifications for 3D shapes, and those are pyramids. In fact, what is a pyramid? Well, a pyramid is a polyhedron. Again, remember, that's just a 3D shape made up of polygons. It is a polyhedron that uses a polygon for the base and then a point that is not in the plane of the base. That point is normally called the apex. And that point, the apex, is connected with a line segment, from each vertex to the apex. So let's go ahead and look at this pyramid that I have over here as an example. The base that we have, I'll color that in blue. You can tell the shape. We're going to name it in just a moment. But this here would be the base. And then the apex is the point, actually, in this case, on the top. So we have our apex right here. Go ahead and we'll call this the apex. Notice that the apex is connected from all of the other vertices with line segments. Now, pyramids can also be classified as oblique or right. How do we classify pyramids if they are oblique or right? Well, an oblique pyramid would be when the apex is not over the center of the base. And then a right pyramid would be when the apex is over the center of the base. Just like prisms, we go ahead and we name pyramids in the exact same way. The first thing that we always want to make sure we say is if it is either right or oblique. And then the second thing that we want to make sure we say is, again, the name of the base. I promised we'd go back to the pyramid that we have up above. Why don't you take a second, see if you can figure out how to name it. If you came up with that it is a right rectangular pyramid, you are correct. You can see the base is a rectangle. The apex is directly above the center of the rectangle, and then it's obviously a pyramid, so that is a right rectangular pyramid. Just like before, go ahead, pause the video, and sketch and name 2 other different pyramids. Again, try to do perhaps one oblique one, and then one with a different type of base. Continue the video once you are finished. Now, we technically have 2 more shapes that aren't necessarily prisms or pyramids, basically because of their bases not being polygons. We have learned, when we learned about polygons, that polygons had to have all straight edges, so anything with a circle or oval base would not be technically considered a polyhedron. However, you guys are probably familiar with these 2 3D shapes. A cylinder is, we'll just say that it is a prism with circle or oval bases. Keeping in mind that that prism term is rather lax because, again, we know that circles or ovals are not considered polygons. Similarly then, what is the relationship with a cone? Well, it would be the pyramid version of a cylinder, so a pyramid with circle or oval bases. You should have enough space on your note guide to go ahead and sketch a brief sketch of both a cylinder and a cone, just so you have them for your own purposes. Once you're done with that, you have finished this note guide.